Hello, welcome to today's lecture, which is What is Reality from Thales to String Theory. By now, you should have viewed the second hour, part two, of The Elegant Universe with Brian Greene, and I will have more to say about The Elegant Universe later on. You should have also used those notes that accompany the video. It's basically a transcript almost of the actual video, so that helps you with spelling of people's names, and I've also put in some commentary as well. By this time also, you should have read the Jim Holt excerpt, Why Does the World Exist? And also listen to his TED Talk. I shall talk about Jim Holt in a couple of days in a subsequent video. Today, I want to focus on the topic of reality. It's sort of an introduction to metaphysics, which is the study of reality. And I also want to go back to the pre-Socratics and bring it forward to the string theorists. So if you have your pre-Socratic handout, please have it ready. And if you have the PowerPoint for this lecture, you may want to access it at this time as well. So just to start, Aristotle said that philosophy begins with wonder. This is something that Plato also said. And I can't think of anything better to talk about wonder than what the string theorists are talking about today. It's kind of strange, weird to think that tiny vibrating strands of energy that are billions of times smaller than an electron make up what we see in the physical world. That's very, very strange. But this is where the search has left us. So I'm trying to reawaken that sense of wonder, which first animated the ancient Greeks many, many years ago. So first, as far as definitions are concerned, metaphysics means the study of reality. I won't get into the history of the term and how it's sometimes used, but in philosophy, metaphysics means the study of reality. When we say reality, we mean that which exists, what is really the case. We mean being. Now, in terms of existence and being, there's a special word that philosophers use called ontology. So that's the study of existence. So if I were to say, for example, gee, does God exist? That is an ontological question. That's how we use the word ontology. So ontology is a subset of metaphysics. So here I'm going to focus more on metaphysics in terms of physical reality. In a few days, we'll talk more about Parmenides, the pre-Socratic philosopher who talked about existence, and also Martin Heidegger. So more on ontology later on. So I want to skip forward a couple of slides at this point and talk about some early concerns among the pre-Socratic philosophers. Before I get there, though, I just want to address very briefly why it was that ancient Greek philosophers were the first ones to deal with this question. Well, we don't really know. There may have been people earlier than this. But if people didn't write things down, we don't have any record of that. There may have been a brilliant, philosophically minded individual 25,000 years ago who had very similar ideas, but we do not have that kind of information available to us. When it comes to the written historical and philosophical record, we really begin, with the ancient, civilizations in the Indus Valley, which gives us the origins of Hinduism. We look at Mesopotamia. We look at the ancient Hebrews. We look at Egypt. And we look to the Greeks. The Greeks, by being a part of civilization, had the opportunity to reflect upon things. They had leisure time, which is what we need to have in order to philosophize. They had the benefit of mathematics that came from other Middle Eastern peoples. The Sumerians gave us the sexagesimal system, which gives us the 60 seconds in our minute and the 360 degrees in our circle. They would have been aware of what the Egyptians did in terms of mathematics. So being at the crossroads of so many things, and having a civilization that afforded certain people to have leisure time and having writing available to them it gives them the opportunity to develop this. There are a couple of other things that scholars have identified. One reason that the Greeks may have developed philosophy and science, whereas other peoples did not, is based upon their ancient polytheistic system of gods. Each god had a certain part of reality in which he or she was in charge. And some scholars have noted that this already shows an awareness that physical reality, the natural world, was apportioned, was divided into certain functions. So I'm going to leave that question aside for now. It's going to take us in a different direction. But let's say that the Greeks had this opportunity to be the beneficiaries of all these other things in the ancient world. When we talk about Western philosophy, we talk about the pre-Socratic philosophers. And, of course, they did not know they were pre-Socratic philosophers. They did not know that there'd be a Socrates coming a couple hundred years later. But we collectively refer to them as pre-Socratic philosophers. Among some themes you want to keep aware of when we get into this is the issue of appearance versus reality. What appears to us may be different than what is actually real. Another thing to keep in mind is the issue of being versus becoming. Is reality one thing that stays the same, or is it in a process of constant change? So that's one of those important things as well. Final thought, the transition from mythos to logos. Mythos, which gives us our word myth and mythology, mythos for the ancient Greeks meant a story or a set of stories that explain the world. And usually these stories are filled with gods and with myths. It doesn't mean that it's fake or false. It means that it's a different kind of explanation. Logos is totally different. Logos is the idea that there is an orderly, rational cosmos that's explainable in terms of natural material causes. We don't need to recruit Apollo to explain why it is that the sun goes across the sky. So the pre-Socratics are occurring at that particular time in human history when there's a transition from mythos to logos. Logos does not mean rational, by the way. It would be very rational, for example, if you were living 400 BCE in ancient Greece, to believe in the gods of ancient Greece. What it means instead is that they're looking for natural material explanations. The first person we turn to is Thales. Now, Thales says that everything is water and the world rests upon water. That to us may sound a little odd. Why water? But if you think about it this way, it's not so strange. Ancient Greece arose out of the waters of the Eastern Mediterranean, of the Aegean Sea. It's the islands, arise out of water. Water comes out of the sky and is necessary to nourish crops. We need to drink water in order to stay alive. Plants need to have water. Animals need to have water. So there's an understanding that water seems to underlie all things that exist. Furthermore, think about it this way. For the ancient Greeks, if they took a pot of water and boiled it, it would turn to steam. The steam would go up into the air and turn into air. However, if you took that same water and it froze, it would turn into a solid. We call that ice. The idea that water could underlie three states of matter is very interesting here. But when Thales says that water underlies all things, it may sound strange to us. We have to give him credit that he's thinking in terms of the broad notion of what is reality. And since I'm talking about that, this is a good point to introduce the word arche. A-R-C-H-E with an accent mark over the E. It gives us our word archaeology, which is the study of human origins. It does not give us our word arch, like in architecture. There's an arch. That's a different root entirely. Arche, first principle or origin or source, means the fundamental building block of reality. So for Thales, it would have been water. For us today, we would talk about atoms or molecules. And hopefully you saw with the string theory film that it gets stranger than that. There are small particles, and below that we have even smaller things called strings. So, but this search for the arche, that's what activated Thales, who, by the way, was a very interesting fellow. Besides his work in with this philosophical question, he was also noted for certain engineering and mathematical feats. He, for example, was able to measure the height of a pyramid in Egypt, not by climbing up and taking a measurement, but by measuring the length of shadows. He took his own shadow at a certain time of the day when his shadow equaled his height, and then calculated that the shadow of the pyramid would be equal to the actual height of the pyramid. So the Greeks are very good with mathematics. This, the mathematics that we would today call geometry. Algebra comes much later, and calculus comes even much later than that. So Thales, no slouch when it comes to science or mathematics, argues that the arche, or first principle, is water. Next up, we have Anaximander, who says that, and if you look at the handout, the unlimited, or the apeiron, is the first principle of things that are. It's that from which things have their origin and where they return when they perish, according to necessity, and render justice to one another according to the order of time. Now, apeiron can be translated as unlimited or boundless. It basically means that there's a substance that's boundless and indeterminate that underlies all of the physical substances and allows for physical change, like water to steam, or the color of leaves to change in the fall, that sort of thing. But I just want to look at this quotation a little bit deeper here. When he says necessity, we'll talk more about this later in the semester, he means the philosophical idea of necessity, that is a natural law, it must be this way and cannot be another way. When he says justice, he does not mean the human idea of justice, although he's borrowing from that. He means that nature kind of follows a balance, a sense of harmony. If there's a drought and that's followed by rain, well, there's been justice, brought to the world. There's a harmonization of dry and wet. So justice, again, points to the idea that nature follows certain laws that provide harmony. And the last segment of his quotation, according to the order of time, is very important. I'll say more about that in a couple of days in my subsequent video, because he's the first philosopher to really call attention to time as a philosophical issue. Next up, we have Heraclitus, who I like very, very much. I took an entire semester in graduate school studying just the works of Heraclitus, and there's a little over 100 of these short quotations. He's a little mystical in places. He's very poetic. Just to read a couple of these things to you, if you follow along, please. Everything flows, nothing abides. Reality, in other words, is in a process of constant change. You cannot step twice into the same river, for other waters, and yet others go ever flowing on. Though, picture me here, not sitting at my desk, but on the banks of maybe the Charles River. I stick my toe into the water, and I pull it out. A minute later, I put my toe back into the water. Is it the same river? Well, it's still the Charles River. But technically speaking, the water that was here a minute ago is now 100 yards downstream. The ripples on the water are now 100 yards downstream. The fish that were here are now downstream. In a very subtle way, the river has changed. This is what he's talking about. Reality is always changing. And not just social reality. We see changes to the downtown and to our towns that we live in. But physical matter is always changing. So I'll come back to change in a minute. Cool things become warm. The warm grows cool. The moist dries. The parched becomes moist. Same idea of reality is in process. It's in the stage of becoming. However, this world is not subject to chaotic flux. Heraclitus understood that the change had to be governed by something. If you threw a ball in the air, it would never be the case that the ball would stop and then shoot off at 100 miles an hour at a perfect right angle. If you boil water, it's not the case that it's going to be turn to ice, it's going to turn to steam. Nature follows certain principles of orderliness. What governs this orderliness? Well, for that, he used the word logos. He has a very specific meaning for the word logos. Logos is that principle of natural orderliness which governs the universe. If you go down a couple of quotations, he says, the universe, which is the same for all, has not been made by any man or God. In other words, the universe is pre-existing, but it has always been, is, and ever will be an ever-living fire, kindling itself by regular measures. And jumping down below that, there is an exchange of all things in fire or for all things. I'll get to that in a moment. And below that one, listening not to me, but to the logos, it's wise to acknowledge that all things are the same. So the universe is this entity which has always existed, which functions according to a certain natural order, which we call logos. Now, what about fire? Fire for Heraclitus was the arche. And by fire, he means kind of a form of energy. I'm not trying to make Heraclitus to be too modern, but if you throw a log into the fireplace, it's going to burn. It'll combust and turn into ash. If you put water onto a fireplace, the fire will cause the water to boil, turn to steam, and go up into the air. The Greeks were aware of the fact that the sun was made of fire. So fire is kind of that principle by which things change. It's different than the logos. The logos is the principle of orderliness in a world of constant change. But fire was that kind of energy that is an exchange for all other things. I love the second to last quotation here. Listen, nature loves to hide. You know, it's kind of representative of the Greek idea of science. It's like, if nature loves to hide, well, then I, as an ancient Greek, am going to play hide and seek with the universe. I'm going to try to uncover that which makes the physical world move. And that's kind of the spirit of the pre-Socratic philosophers. Next up, we have Parmenides, whose focus is on being. It doesn't reduce quite easily to the idea of arche, and I shall talk more about Heraclitus later when we talk about Jim Holt. But just here, in general, if you look at the quotations on the passage, it's necessary to both to say and to think that being is. For to be is possible, and not to be is impossible. Parmenides, in other words, and he wrote in poetry, by the way, is saying that talking about nothingness doesn't make sense. You can't have something arise from nothing, which is the point of the second passage. One road only remaining to be spoken of, that is. And on this road there are many signs that what is has no beginning and never will be destroyed. It is whole, still, and without end. It neither was nor will be, it simply is. How could one go about investigating its birth? I shall not allow you to say or to think of it as coming from not being. So you can't have nothingness create being. It wasn't the case, like some mythological systems argue, that there was nothingness and then some god created a somethingness. And this is something that Jim Holt talks about a great deal more, and I shall talk more about Parmenides and Jim Holt in my next lecture. So Parmenides, very interesting, and we shall return to him. Empedocles, very interesting. He gives us, and he's not the only one, but he gives us the notion of the four elements. For him, it's earth, air, fire, and water. And he acknowledges that change does happen. The experience that we have of objects is always changing, but the basic parts do not. The atoms, if you want to use that word, do not. Empedocles, in fact, says, if you look at the quotation here, there is only mingling and interchange of parts. And it is that, and it is this that we call nature. Farther on, he talks about earth, billowy sea, moist air, and giant sky, in the sense of the sun filling the sky. A mingling and interchange of parts. This is kind of what you study when you study chemistry, how different atoms come together to form molecules. So this was his principal idea. I'm going to move on next to Anaxagoras. And Anaxagoras, as I say in the handout here, argued that each kind of substance has its own kind of particle. As he says famously, for how could hair come from what is not hair, or flesh from what is not flesh? There must be some kind of hair particle which gives hair its kind of hair essence, and some kind of flesh-like particle that gives flesh its fleshy essence. As he says in the fourth passage I gave you, whatever there is most of in particular things determines the manifest nature that we ascribe to each. So wine, for example, is mostly water. Hence, wine is watery. But there are other things there. But it has water in large proportion, which makes it a liquid. There are other proportions of air and of sun and of earth that make wine what it actually is. So again, kind of zeroing in on the idea here that there are smaller parts of reality of which we are not aware. We cannot see them. The next group I want to talk about here quickly are the atomists. And the word atom is a Greek word. The Greeks gave us the concept of atom over 2,000 years before we actually knew that atoms existed. So they did this without chemistry or physics. They did this through deduction and through induction as well. So there are two people here just to call attention to. The first is Leucippus, and the second one is Democritus. For Leucippus, I actually pulled out a different quotation, not having him talk about atoms so much as about the idea of orderliness. If you look at Leucippus, nothing happens at random. Whatever comes about is by rational necessity. Again, the idea if you throw a ball in the air, it's going to come back to your hands. If you boil water, it's going to turn to steam. It's not going to turn to ice. Nature follows orderly principles, and these orderly principles govern these tiny unseen elements that we can't quite see. Now, Democritus, he's much more explicit in the quotation I gave you here about the nature of reality. It's the nature of eternal objects, quotes Aristotle, to be tiny substances, infinite in number. He conceives them as so small as to elude our senses, and none of us can see an atom. It's too small. But as having all sorts of forms and shapes and different sizes. Treating these as elements, he conceives of them as combining to produce visible and otherwise perceptible objects. Atoms come together, form molecules. When you have millions of molecules, you've got something that we can identify, like a piece of paper, like the top of a desk. So the idea that the world is made up of tiny things called atoms that we cannot see goes back to the atomists in ancient Greece. In the next paragraph, he talks about these elements bumping and grinding against each other, which is interesting speculation. It's not unlike what we do in chemistry. We talk about different kinds of chemical bonds, how atoms can come together, but you can always pull them apart. You can take apart the molecule and go back to having the fundamental atoms or elements that we have in the periodic table. The last page of the handout talks about the Pythagoreans. And this is something I'll come back to and talk more about. For Pythagoras and for the Pythagoreans, and by the way, you probably know Pythagoras from the Pythagorean theorem that you studied when you took geometry. For them, reality was mathematical, essentially. The world was mathematical. They knew that by looking at the motions of the planets, noting musical harmonies played on a particular stringed instrument, noting the ratios of measuring different objects, by doing geometry, that reality was inherently mathematical. So what's very interesting about this is that we see a similar question emerging today, and I put into your PowerPoint a quotation from Galileo, pondering why is it that the world is mathematical? Why does math help us do physics? Maybe math, deep down, is what the world is all about. So without making Pythagoras too modern, I just want to point out that we will be returning to this notion of the mathematical nature of reality. Pythagoras had this in play 2,000 years earlier. Finally, Xenophanes, who I will not talk about right now. He focuses on gods, and he points to the fact that the ancient Greek gods seem very human to us. They're kind of anthropomorphic. And the sophists later on who say that man is the measure of all things. We shall return to that later on. The bottom line, by looking at all these pre-Socratic philosophers, is the following. We see in ancient Greece an effort to try to understand the natural world, not with science laboratories and things like that, but through deduction and induction, asking certain questions and trying to comprehend physical reality. It's philosophy. Today we say it has to do with science, and that's true. The connection between philosophy and science is something I'll talk about when I talk about Bertrand Russell in my next lecture. But for us today, it's important to understand that philosophy and science are one and the same in terms of how they originated in ancient Greece. I just want to move on a little quickly to some of the other thinkers we have here as we go forward. I'm going to skip past the Galileo quotation from the Assayer. We'll talk about that later on. And say something about the string theorists. The string theorists today are really engaging in the same quest that the pre-Socratic philosophers were engaging in 23, 24, 2,500 years ago. That makes the pre-Socratics very modern, or you could say it makes the string theorists today very ancient in terms of their quest. It's been an enduring quest of humans to comprehend reality. We have the benefit of lots of technology and lots of other science, but the quest remains the same. I ask you, what's stranger? Is it stranger to think that the world is made up of tiny vibrating strands of energy that no one can see? Or to say that water makes up reality? You know, there's a lot to recommend Thales here, I would say. So there is a connection between what the string theorists and all physicists and chemists are doing today with what the ancient Greeks were doing. String theory, of course, I hope you saw this from the film, unites general relativity that was developed by Einstein and the principle of quantum mechanics, because these two sets of laws were very, very different. String theory kind of unites these. However, as you saw from the film, it's based upon mathematics, which is not a problem for some scientists, but it is for others. There is no experiment, there is no observation that you can do. So for some people, string theory remains very, very speculative. By the way, I ran into Brian Greene at a conference a few years ago, and I asked him, I said, you know, what would you change in the video if you were doing it today? He says, basically nothing. It's all pretty much the same. We're stuck with 5 different variations of string theory, with certain physicists working in the area of string theory. Some people are rejecting that, and physicists moving on to tackle other problems. We'll talk later about string theory as something that deals with the issue of scientific truth. Do we think it's real, or is it just some kind of an invention that works? You know, we'll get to that later on. Here's one thing, though. If you remember from the string theory film, there's a scene near the end where Brian Greene is sitting at a console and he's twiddling these knobs, you know, these about 20 fundamental constants of nature. I want to come back to this later on in the subsequent lecture, but here's my question for you to ponder. Why these numbers and not different numbers? Why is the weight of an electron what it is? Why is the speed of light what it is? Are these things necessarily the case? Or are they, to use a new word we'll introduce in a couple of days, contingent, i.e. they're kind of arbitrary? What's at stake here is the issue of mathematics being a representation of the physical world. So I shall return to that particular point. Last point I wanted to make as I move towards concluding this lecture is that when we talk about reality today, we oftentimes talk about materialism. A materialist says reality is matter. It's this table in front of me. It's this book over here to my side. You know, matter is real. But today, we don't use the word matter very much. We still use it sometimes, but modern physics has given us a strange idea of matter. Matter does not end with the molecule or the atom or even the particles. It seems to go back down to the level of these tiny vibrating strands of energy. So instead, we sometimes use the word physicalism. Physicalism says everything that exists is physical. Matter may not be the end of the road, but reality is ultimately physical. What is physical? Well, what's physical is produced by the intersection of these four fundamental forces of nature: gravity, strong force, weak force, and electromagnetism. And these things combining together, of course, in something called space-time. That's one word, space-time. We'll talk more about that later on. And this, of course, raises a very provocative question, especially when we talk about these extra dimensions of space. This raises the question of, what do we mean by space? What is space? What is time? For now, I'm going to hold on to that, and we will talk about that in the next lecture when we talk more about time, space, quantum mechanics, and Jim Holt. Okay, thank you very much for joining me. I hope you have a good day. Talk to you soon.